Hey guys, I hope you all got to take your quiz yesterday and are understanding periodic trends and ionic bonds. We're going to be going on to covalent bonds. So I'm going to go through these notes and then I'll have a separate video going over the worksheet for you. So that one should be pretty short. Alright, so we're going to do covalent bonds. We're going to define what they are. We're going to compare and contrast polar and nonpolar covalent bonds. We're going to look at Lewis structures to represent covalent bonding. It's a little bit different than ionic bonding. We're going to define electronegativity and use that to determine our bond type. The other learning targets we're going to probably do next week. So, our molecules exist as discrete units held together by covalent bonds. So molecules are held together by covalent bonds. If it has an ionic bond, it is not called a molecule. Okay, so keep that kind of in mind as you're using different words. A covalent bond has a pair of electrons that are shared by two atoms. So this shows when we have a hydrogen and a hydrogen, each has one valence electron. That one s orbital is overlapped and their electrons are shared. Okay, and that forms a molecule. Here's an example with chlorine, and instead of chlorine having an s orbital overlap, the p orbitals actually overlap. Okay, so we've got our unshared electrons, their lonely electrons. We're gonna circle those instead of drawing an arrow, and that's going to show that they're shared, and that's showing that this orbital is overlapping. So that electron can be anywhere in that orbital. Both of those electrons, I should say. Some other diatomic elements. Remember, we have hydrogen. All of our halogens are diatomic, and then single bonds are formed in hydrogen and the halogens. Okay, because they're going to share. They're going to share one set of electrons. Okay, and again, I'm going to show you guys this when we do our homework too. If we have two pairs of electrons shared, like in oxygen, then we would have a double bond. Triple bond, like in nitrogen, is when we have three pairs of electrons, and we can draw it with three pairs of dots or three lines. Each shows a triple bond. A double bond could be two lines or two pairs of dots. Electronegativity is how attracted an electron is to one atom versus another. Usually, I shouldn't say usually, but a lot of times one atom's going to pull the electrons more towards it than the other. And I'll show you an electronegativity chart in a little bit. Basically what this means is that chlorine has a higher electronegativity than hydrogen. It's going to pull the electrons closer to it more often, which actually makes this slightly positive. So your hydrogen is slightly positive, and we use this little, like, I don't know, SD. It's actually a Greek D, I believe, but it just means slightly. So slightly positive hydrogen because the electrons are being pulled closer to the chlorine, which makes the chlorine slightly negative. Okay, I just said that. Here's an electronegativity chart. I also shared one in classroom for you. So all of the electronegativities have been determined. So if you look at that last example, we had chlorine, which is a 3. Hydrogen is a 2.1. Chlorine is going to then pull electrons closer to it than hydrogen because its electronegativity is higher. When we look at bonding, the difference in electronegativity between two atoms is what determines what type of bond it is. So if we look at something that's greater than 2, the bonding is ionic. So if I go back, let's say I have sodium chloride. So sodium is 0.9, chlorine is 3.0. So the difference between those is 2.1. Okay, it's an ionic bond because it's greater than 2. If the bond or electronegativities are equal to 0, the bonding is covalent with equal sharing. So if I had H2, for example, well, hydrogen is not going to be more electronegative. Have a higher electronegativity than hydrogen, so it's going to be 0. But there's other instances too. I'm trying to think of other examples, but if they have the same electronegativity, the electrons will be shared equally between. And then if it's between 0 and 2, the bonding is what we call polar covalent, which means that there is an unequal sharing of electrons. So HCl, okay, we have 3 minus 2.1 is 0.9. Okay, that's going to be between 0 and 2, so that means that there's unequal sharing of the electrons. And it's a polar covalent bond. Nonpolar covalent bonds have very, very small or no difference in electronegativity between the two atoms. The electrons, again, are shared equally. So it's carbon and sulfur would be an example. So if we take 2.5 minus 2.5, we get 0. That means that it's nonpolar. If we have nitrogen and chlorine, they're both 3. So again, it's a nonpolar covalent. Polar covalent, if they are shared unequally, again, electronegativities are less than 2. So if we have phosphorus and oxygen, phosphorus electronegativity is 3.5, oxygen is 2.1. We get 1.4. That means it's going to be polar covalent. Okay. Nitrogen and carbon, same thing. It's less than 2, so we get an electronegativity difference of 0.5, and it's a polar covalent bond. There is a continuum of ionic versus covalent. This is just saying if there's a electronegativity difference of 1.9, so it's greater than 1.7 to 1.9, the bond's going to be more ionic than covalent. So this is going to be a more ionic bond. If it's greater than 2, it's strongly ionic. So silicon and fluorine has a 2.2, it's going to be strongly ionic bond. If it's less than 1.5, it's going to be strongly covalent. Okay, but if it's in this 1.7 to 1.9, it means that the bond's more ionic than covalent, but it's not, I would say, more of a weak ionic bond. Okay, a bond that is principally ionic will form between what? So if you go back to your electronegativity table, you could see that your answer is going to be magnesium and chlorine. You also know that ionic bonds are generally between a metal and a nonmetal. Then you would know that it's A as well. Polar covalent bonds will form between which two atoms? Okay, go back to your electronegativity chart, do your subtractions, okay, and see which one is going to be a polar covalent. Well, we know hydrogen and chlorine are, right? So the answer is probably B. Did we do it? Did we define a covalent bond? Did we look at polar versus nonpolar covalent? We haven't done this yet. I'm going to show you that when we do our assignment. And we also looked at electronegativities and their differences to determine bond types. Okay, you guys are going to do your worksheet. That goes with it. So here's the electronegativity chart. It's in with the notes. Your covalent bond worksheet, I'm going to, again, go over this with you guys separately, but the first part is to figure out protons and electrons, valence electrons, and then the number that are needed to fill the outer shell. We're going to do the dot structures together, you're going to have to take a picture of this and do it on a separate sheet of paper and take a picture. Okay. Again, I'm going to show you how to do dot structures for covalent bonds in a little bit. So, all right. I hope you guys have a great day, and I hope you're all doing well. Miss you guys. Bye.